Okay, so as I was saying, when we were going through the non-calculator paper on Tuesday, I was a wee bit concerned in regards to our answers for the inequalities. Okay, so I'll just start with a wee bit of inequality stuff and go through that. Okay, so I've tried to put all the past papers that I'm referring to, try to put them on that. Okay, so should be available to you. 2 seconds, just need to calibrate this bloody board. Question that's referring to. Okay, so an equation. In equations, we just treat the same, exact same as we treat equations when we're rearranging. Okay, so the equation you get given is usually quite a nice set of numbers and letters. Okay, what we're trying to do is get everything with an x beside it over to one side of the equation, and everything in a whole number over to the other. Okay, so the x is on the left hand side, the whole numbers on the right hand side. There's one rule we need to remember here, okay, and that's when we need to flip this sign, okay, this sign, okay, the greater than or less than sign, okay. So we do that when we take across a negative number to divide on the other side, okay, and that's really important, not only when we take across a negative number, as we'll see later, but when we're dividing by a negative number, only when we're dividing. So start writing that out. Hopefully purple's okay for you guys. Fine. Black. Okay, so if we start writing that out, I'll just write the full thing out. First thing I'm going to do here is just break that bracket up. Okay, so I'm going to do nothing to the left hand side. I'll break that bracket up and I'll just tidy that up. Okay, quite like terms. -6, -12 is just -18. Okay, now I'm left with that. So as I said earlier, I want to get all the x terms on the left hand side of that equation. So at this point, I'm just treating that like I would an equal sign. So that's 6x on the right hand side, I can take over to the left hand side and it becomes a negative. Okay, so tidying that up, I'm getting -3x, -18. Now this is the part that we need to be aware of. Okay, this is the bit where we need to be careful of. When I'm taking over this negative, okay, because it's a multiple on the left hand side and I'm taking it over to the right hand side, it's going to become a divide. Now I'm going to divide it by -3. But because I'm taking over a negative, I flip that sign. It's going to be x on the left-hand side. The sign flips round and points in a different direction. It's -18 over -3, which gives me my final answer. Okay. If I go too fast or you're still copying it, give me a wee shout. Likewise, very similar. Okay, so this is just a past paper from another year. Okay, very similar setup. We've got a bracket on the right hand side there. That's sort of the first thing I want to deal with. Okay, we've got some whole numbers on the left, got whole numbers on the right. Okay, again, we want to do the same. X is on the left hand side, whole numbers on the right. Just going to break that bracket up and tidy up the right hand side so I do nothing to the left. So plus 3x minus 2, no, minus 6. Plus 3x minus 6, okay. Tidy up that side, so 15 minus 6 would be 9 plus 3x, okay, so only collecting like terms. I now want to move all my x's over to the left hand side and all my whole numbers over to the right. So that 3x comes over, becomes a negative. The sign stays the same at this point, and the 19 goes to the other side. Okay, got -2x and that will be -10. Okay, so the sign hasn't changed yet. I'm now going to look at that, and I'm taking away, sorry, I'm removing that -2 so I can isolate the x. We want to leave the x on its own when we're doing this. So I want to isolate that x, so I need to remove that -2 and move that to the other side. So I'm taking it across and I'm dividing by a negative. Because I'm doing that, the sign flips. So I've got -10 over -2. That simplifies down into +5. Okay. Setting that for a wee bit. Am I losing anyone anywhere? Very good. Okay. I'll do one more and then I'll get you to do one. Okay. So same again, the brackets on the left-hand side this time. Nothing's changing the way I'm approaching this. Okay. Going to break that bracket first. Now, just be careful because that's a -2. So it's going to be -2 multiplied by everything in that bracket. So -2 times +1 is -2. -2 times +3 is -6x. Okay. And that nothing happens to the right hand side. Tidy that up. And then keep the x's on the left hand side, move the whole numbers. And then be careful because we're flipping the side of a negative. So the sign changes. We're getting through that. All right, so these are pretty common questions, so I thought that's why I just covered it again. Okay, so you've seen one in the prelim. It wasn't particularly well done, so I just thought I'd cover that. Okay, so you've seen 3 there. You give that a wee go yourself. Okay, the answer's there, but if you work through that yourselves, okay, try and get to that answer. That. Okay, so again, we've got a bracket here. We've got x's in both sides. Okay, 13 plus 4x. Same thing, I'm just going to break that bracket up. Just be careful with the sign, so that's -14, and then that negative times a negative is going to give me a +x. Okay, so 13, in fact, I'll just tidy that up, it's 4x. That'll be 4 plus x. Okay, so moving all the x's over to the left-hand side and all my whole numbers over to the right-hand side. (7x), that's fine. Maybe going something wrong somewhere. All right, 7x. Okay, so moving all my x's over to the left-hand side. All my whole numbers over to the right-hand side. 4 minus 13 is -9. All right. Moving that negative over, flipping that round. -9 over -3, x greater than 3. Okay, so quite a lot involved in that one. There's quite a lot going on in that line. okay, but nothing changes. We break that bracket up, all our x's go to the left-hand side, all our whole numbers over to the right-hand side. The rule we need to remember is if we are taking a negative over 2 divide by, okay, we flip that sign around, okay? That's what the inequality question always has involved in it. All right. Any questions on inequalities? Nice wee question. Couple of marks. Nailed it. Oof. So move on to another equation, type of equation. It needs a wee bit of rearranging. Okay, this time there's fractions involved. Okay, so what's going to happen is we're going to try and solve that fraction. Okay, we're going to bring it all together so we can start simplifying it. Now, what we need to happen is the same denominator in both of these fractions to allow us to start simplifying. So one's got a 3 and one's got a 6. Okay, now there's different ways of doing this. I'm just going to stick to the kiss smile. Okay, and then bring them all together. Okay, so kiss smile, 2x and the 6 is going to multiply together. Give me 6x. Okay, the 5 and the 3 are going to multiply together. Give me 15. And then the bottom two numbers multiply together. Give me the smile. Give me the 18. And that will equal 2x. All right. This point, again, few ways of doing this. Okay, we could simplify that left-hand side, or we could just bring that 18 over to the right-hand side straight away and just multiply that. Okay, so I'm going to do that. $18 comes across, so it'll be 18 times 2x. 6x minus 15 equals 36x. Going to bring the whole number. Okay, so now I want all my whole numbers to come across the right hand side, and all my x's go the opposite direction, go to the left hand side. Okay, so it'll be 6x minus 36x equals 15. Okay. So that will give me negative 30x. I've gone wrong somewhere. Should give us negative a half, which is more right. Where have I gone wrong? 36. 18 times 2. Was it 15? $12x. Why is it 12x? Bang on. My God. There we go. 12x. That's right. Thank you. Sometimes too close to it. Right, that'll leave that out. Yep, so another cross multiplied, that will be 12x. Perfect. That top line will be 12 as well. So that top line will be 12, 12x over 15, blah, 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 blah. 12x here, 12x here. So that will be 24x equals negative 24x equals 15. X equals 15 over negative 24. And then that's a case of simplifying that down. Okay, so 3 goes into both of them. You get negative 5 over 8. Thank you very much. Okay, so silly mistake there. I would have still got a few marks, right? I'll blame being too close to the board. All right, but does that make sense? So that cross multiplying bit is the main part of it. Okay, the bit that I got wrong. Okay, so that's the main part of it. Doing the 2x multiplied by 6, -5 multiplied by the 3. Okay, so that's quite a nice one in 2016. Have we look at this one? Okay, now the difficult part with this one, people get thrown by the fact that x is on the bottom there. All right, so we're going to have to deal with that at some point. Okay, so we'll think about how we do that as we go through. Now, what we cannot do is move that across at this stage. Okay, we need to deal with this equation in a certain order. Okay, and that x, if we moved it too early, will affect that variable there. Okay, or that number there. So I'm going to move that whole number across. I can move that whole number over to the right hand side and just leave myself with 2 over x. 16 minus 9 is 7. Okay, now x is on the bottom there. I can't just take that 2 across and be done with it. Okay, if I took that 2 away at this point and left the x on the left hand side here, I'd have 1 over x equals 7 over 2. Okay, now that's not what I want. I want x on the top line. Okay, so just be careful with that. So what I need to do here, what you need to do here, is leave the 2 on the left hand side and bring the x over. Now it's a divide on the left hand side, so it becomes a multiply on the right. Okay, and then to isolate x, I bring the 7 across, so it becomes 2 over 7 equals x. Okay, and just plug that in. Perfect answer. That's quite a fiddly one. Being it looks relatively simple, okay, but it throws you the fact that that x is on the bottom of that line. All right, we need to get that up to the top somehow. Okay, but we need to move it at the right time. We need to get rid of all the whole numbers first from that left hand side over to the right hand side. Okay, so it's a wee tricky one. Any questions on that? Okay, this again is quite a wee tricky one. Okay, because we've got fractions on both sides. Okay, so that's a 2019 paper one. Okay, so we chance up x over 2 minus 1 equals 3 minus x over 5. Again, there's a few ways of doing this. Okay, and there's no right or wrong way of the way you can do this to get to that answer. Okay, the way that I look at that and want to do it is bring all the x's over to the left hand side and put all the whole numbers over to the right hand side. Okay, I might show you another way of doing this as well, but I'll do that one first because it stays consistent. So that x over 2 stays there. That minus 1 goes over to the right hand side and becomes a positive 1. This whole term here moves over. Okay, and becomes negative on the right hand side. So everything I see there moves. You get that? Okay, so I can move that whole fraction across over to the left hand side, and that whole fraction becomes negative. Now, what I want us to be careful here with is now the multiplication when we do this cross multiply. Okay, because this x will become positive. Oh, that'll be 5x. Okay, that's our first multiple. And then I'm going to do this. Okay, so it becomes -6, and then positive 2x. So 7x. I keep getting these wrong. What's happening? X minus 2 minus 3 plus 2x. Oh, I've not done over 10. Thank God. Sorry. Okay, so multiply, multiply, and then remember the smile bit. That dummy. We'll point all it. All right, so 7x minus 6 over 10. 1, bringing the 10 across. 7x minus 6 equals, that becomes a multiple, so it's just 1 times 10. Becomes 10 on that side. 7x equals 10 plus 6. 7x equals 16. Okay, I'll move up a wee bit. 7x equals 16. So x will equal 16 over 7, which is good. All right. To answer Emma's question, sorry, yes, you can leave it as 2 over 7 equals x. That was fine for the last question. Okay, does that make sense? So remember to put everything bloody in it, which I've forgotten twice now. Any questions on that one? I was going to show you another way of doing that, wasn't I? Okay, what we could do here is bring this 5 across over to the other side. Now, if I bring that 5 across, it's a divide on the right-hand side. So it becomes a multiple on the left-hand side. But I need to multiply everything on the left-hand side by that 5. If I do that. Okay. If I bring that 5 across, I essentially have a sum 5x over 2 minus 1, 3 minus x. Okay, so that will give me 5x over 2 minus 5 equals 3 minus x. I can tidy that up a wee bit by bringing the x over. Taking that 5 over. Okay. And then I can just tidy that up. So remember, if there's ever a number or letter on its own, and there's a fraction involved like this, and you're trying to tidy that up and don't really know how, remember, we don't write it, but essentially that's divided by 1. Okay, and that means we can do our kiss smile at that point. Okay, and tidy that up. Okay, so I'm going to do the kiss smile. It's 5x times 1, just be 5x, plus 2 times x, so plus 2x, all over 2 equals 8 on that side. Now I can take the 2 across and tidy up the x terms. Give me 7x, and it'd be 8 times 2 would be 16. And then I'd be left with the same answer. Okay, so a wee bit fiddly. Okay, quite a lot going on, considering it doesn't look like it. Okay, but that's just another way we can do that. It's just another way of tidying that up as we go along. No bother, Dylan. Any questions on either of those methods? So if you've written them both down, look at them both. All right, make sure that you're comfortable, or you can at least see what I've done at each stage. Okay, maybe not be comfortable with it, but make sure you're you can see what I've done at each stage of that. Give it a go yourself. Okay, again, I'm going to let you try something here. Cool. Stick to the method you prefer. All right, try this one. Okay, I'll give you till 1:15. There's a wee bit more involved in this one. Oh, 1:15, my God, that would be a long one. I'll give you till 1:45. Okay, so quickly do this. So cross multiplying again. So the 3x minus 1 gets multiplied by the 2, the bottom there. So check those. 6x minus 2. 3 comes across. Now this negative throws a wee bit of confusion in here, okay? But it will become negative 3x and then positive 9. And then the bottom line will be 3 multiplied by 2. And that will give us equal 1. Okay. We bring the 6 over and tidy up that line, bring all the numbers together. Okay, so we'll have 3x plus 7. If 6 is a divide on the left hand side, so it becomes a multiple on the right hand side, so it'll be 1 times 6 or just 6. Okay, we can move over that 7 and then finally move over that 3 to the left of that. Okay, again, not a very nice one. Hopefully it's nothing that bad. Okay, this bit throws a lot of people having a negative here and then cross multiplying. Okay, so just be careful with that. Anyone get anything different that they want to share? I believe you. All right. That point, guys, let's take a wee break. Okay, that's just been 45 minutes, but let's just get a wee freshener because it's quite warm. Very, very stuffy here. So let's take a wee break just till 7 o'clock and we'll come back together and I'll just do some trig graphs. Okay, guys. If anyone's got any questions. Okay, so next wee bit I want to look at or do a wee reminder of, we never touched on this at all on Tuesday really, is the sort of trig and trig graphs and how we use them. Okay, so go over the sort of basic features of the trig graph. Okay, I'll go over the format of how we'll see them written out. Okay, and then I'll go into the cast diagram and just go over that stuff again. Okay, so really sort of foundation stuff, and then I'll allow you to build on that yourselves. Okay, so trig diagrams, trig graphs. Hopefully we've managed to have a wee look at these. Okay, they come in the most basic formats: y equals sin x, y equals cos x, and y equals tan x. Okay, so y equals sin x. Then them all in white. All right. When we see a sine graph, okay, what we're looking for is these milestones that I like to talk about. Okay, now the graphs, in essence, will start at 0. Now, sine, just a normal y equals sine x graph, will be at that point. That's where it will start, 0. We'll go up to a peak, we'll go down, cross through x again, at a negative, and then finish off back at the x-axis. Okay, so that shape is typical for sine. Okay, we're starting at 0, we're going up to a peak, down to a minimum, and back up to the x-axis. So each of these milestones that I'm talking about occur for y equals sine x at 0, at 90, 180, 270, and at 360 degrees. Okay, 360 degrees. So between 0 and 90, a sine graph is increasing from 0 all the way up to a maximum of 1. Okay, so between 0 and 90, y equals sine x is always going to be positive all the way up to the peak of our chart. Okay, sine x or sine 90 equals 1. Okay, gives our maximum. Between 90 and 180, it's still positive, but it's starting to go down. So that's another 90 degrees. So something's happening every 90 degrees. 0 to 90, where there's a maximum. 90 to 180, a further 90 degrees. We're now crossing the 0. We're crossing the x-axis for the first time. Okay, so we're crossing the x-axis the first time. After that x-axis, after 180, sine goes into being negative. So from 180 to 270, okay, which is another 90 degrees. Okay, which is another 90 degrees. Sine x is going to be negative. Okay, so everything in there, so sine 180, sine 190, sine 200, sine 210, they're all going to give us a negative answer. Okay, if we did that equation. Finish that off then, sine 270 to sine 360, we're increasing from our minimum of -1. Okay, and we're going up, back up to the x-axis, when the x-axis is at 360. Okay, so there's a milestone every 90 degrees. Okay. Now, one of the things that we might have to do with these is to look at sketching them. Okay, we might have to sketch these in the exam. Okay, now when we sketch these, we're going to change certain things about it. So they're going to give you this y equals sine x, but they're going to add something else into it. Okay, so the format of y equals a sine bx plus c. Okay, where a in this case is the amplitude, which is where our max and minimum is. Okay, so that number in front of the sine, okay, if it's a 3 sine blah 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 blah, that tells me where my max and my min, how high we're going to go. Okay, how high this number and this number is going to go. Okay, my bx is an interesting one. Okay, we call that phase, but that's how many waves, how many sine waves between 0 and 360. Okay, so if that said sine 2x, that means this whole wave that we've shown here, okay, that sine wave, which has the milestones of 90, 180, 270, and 360, well, it's actually going to occur twice in the same distance along the x-axis. Okay, so sine 2x would mean that the milestones would be 0 to a maximum of 45. It would cut through the x-axis at 90. It would go to a minimum at 135, and then it would complete the full wave at 180 and then start again. Okay, remember what these waves, sine waves and cos waves are showing us. They're showing us repetition. They're showing us something happening over and over and over again. Okay, they can demonstrate rotation, a pendulum swinging, a tide coming in and out. Okay, they're showing us repetition across a certain amount of time. Okay, so that's 0, 90, 180, 270, 360 is your typical milestones. That B, if we put a number in that position, we're going to change those milestones and we're going to affect, okay, how many waves are going to be between 0 and 360. C is movement on the y-axis. Okay, so for +1, that means our start point is moved up the y-axis by 1. Now that's going to change where the start point is. That's going to change where the maximum and the minimum is going to occur. And it's also going to change if it's going to cut through that x-axis. Okay, so it's important when we're moving that up and down that we know where that's going to be. Okay, so that's not going to change the milestones per se of 0, 90, 180, 270, and 360, but it will change where on the graph that's going to start. So it will move away from 0. Okay, so it's either going to move up or down, depends if it's positive or negative. Okay, but it will affect where it starts on that y-axis. Okay, so A, amplitude, how big the peaks and troughs are. B, how many sine waves we can get in between 0 and 360. C is movement on that y-axis. Another format in which they can do it, okay, is if they put it y equals sine, and then in a bracket they've got the x and plus or minus, but I'll put minus and I'll just pick a random letter. It's D, it's the next one along. All right. If you see that setup, that's going to move it move the sine graph. That's well graph. Along the x-axis. So that's going to move it horizontally. That's going to move your start position either to the right or to the left. Okay, so that's an important one when we're sketching to understand where that start position is going to be. Now, the tricky part of this, okay, when this is a negative, the graph moves right, which is sort of counterintuitive. And if it's positive, okay, it moves left. Okay, so there's quite a lot going on just by looking at that graph. Okay, but remember what this graph is trying to tell us is there's going to be repetition, okay, within our system. That comes important when we do the more story-like questions when we're talking about trig. But this is just a repeating system, up and down and up and down and up and down, or round and round and round. Okay, it's just repetition along that x-axis. Okay, so we can do certain things, change the amplitude. We can put more waves in that same period. Okay, so we speed up. Okay, so we can speed up the rotation. We can speed up how fast the pendulum swings. The tide can move faster or slower in and out. Okay, more waves are going to occur, more repetitions going to occur. Okay, we can move it up the x-axis, we can, or along the x-axis, or we can move it in the y-axis. Okay, so you need to be aware of all these when we go to sketch graphs out. Okay, don't think we did any of that in the prelim. Now that is not an indicator of whether it's going to be in an exam, but look, it'd be a good one to know. Okay. Any questions on the sine graph? Okay. Now what I'm going to do this stage, it might help. Okay, is I'm going to draw the quadrant in this format. Okay, and write out 0, 90, 180, 270. Okay, so between between 0 and 90, so between 0 degrees and 90 degrees. So between 0 degrees and 90 degrees. Okay, and this first quadrant. Sine is positive. Okay, so that cross that I've drawn there, on the right hand side where I've written 0, that means 0 degrees. So as I rotate around that center point of the cross, okay, think about like a clock. Okay, it's going anti-clockwise, but think about it as a clock. So as I'm going from 0 to 90, that represents the x-axis, what's happening at this x-axis. I'm traveling from 0 to 90. At all points, as I'm traveling from 0 to 90, sine is positive. Yeah. Okay. Starting at 90 this time. Top of the graph. Traveling to 180. Again, sine is all positive. Okay, so that 90 at the top of that cross this time means I'm starting at 90 degrees. As I rotate again anti-clockwise around my center point of the cross. Okay, rotate around there. Sine on my graph is always positive. Between 180 and 270. Between 180 and 270. Sine is always negative. between 270 and 360. 270 and 360 on my cross. Again, sign is negative. Okay. So just have that there. Okay, just have that there and we'll refer back to it in a minute. Oh, perfect. Y equals cos x. Okay, will give us a graph in that shape. It's got the exact same milestones. Okay, so just in its most basic format. Y equals cos x, 0 to 90, 180, 270, 360. Okay, slightly different to the sine graph, where at its start position, where it's 0 on the x-axis, we're starting with a maximum point. Okay, so cos's maximum point is when x is equal to 0. As it travels from 0 to 90, cos is all positive. As it travels from 90 to 180, okay, cos is all negative. That takes us down to our minimum at -1. Between 180 and 270, cos is all negative. Okay, it's underneath the x-axis. And to finish that off, 270, 360. Okay, is all positive. So again, these 4 distinct milestones where something important happens, okay, happens every 90 degrees, 0, 90, 180, 270, 360, when y equals cos x is in its simplest. That's our start basis when we've got a cos. Okay, again, this just shows repetition. It goes from a maximum to a minimum to a maximum, maximum, minimum, maximum. Okay, it's just a wave, just rotation. It's just a wave coming in and out, in and out. Okay, it's just at this time we're starting with a maximum instead of sine, which starts at 0. Same way, we can change the format of that and have to sketch it. Okay, so the same letter sort of combinations they use. Amplitude changes our max and min. Changes the amount of waves between 0 and 360, and that changes the y-axis. Okay, or it can give you cos x minus e, where that is movement along the x-axis, with negative being to the right, positive being to the left. Okay, that will affect where these milestones sit. Okay, so when we're sketching it, that's what you need to be aware of. That's our golden rules. Start always, I would say, when you're doing these sketches, with the normal when y equals cos x, your normal milestones, your normal amplitudes, your normal position of the graph. Okay, just a wee rough sketch every time. Okay, so you know where your maximums start. Okay, so when you put in an amplitude and you move it up the y-axis, you've got something to refer back to and just give yourself a wee reminder. Okay, that's not one. wanting to achieve tonight, though, what I'm looking for is to understand these cast diagrams. Okay, so similar to what I did with sine on the same graph, okay, a separate one, but between 0 and 90, 180, 270, okay, between 0 and 90, cos is positive, okay, so between 0 and 90, all positive. Okay, everything's above the x-axis. All our solutions are above the x-axis. Okay, between 0 and 90, solution we'll get for a cos in there will be positive. Between 90, 180, cos will be negative. 180 to 70, cos is negative. To 70 to 360, cos becomes positive again. Okay, so that's sine graphs and that's tan cos graphs. Okay, the tan graphs are very different. We don't sketch these graphs. All right, you will never get asked to sketch them because very difficult. All right, because they approach infinity essentially. But well, what you do need to know for tan graphs, and I'll show you what they look like. So 90, 180, 70, 60. Okay. Tan graphs play a part in this cross as well. Okay, so between 0 and 90, tan goes from 0, it sort of approaches infinity. Okay, it goes into that shape, which is really weird. Okay, but all our solutions, okay, so you'll never get asked to sketch this, but all our solutions in there are going to be above the x-axis, so they're going to be positive. Okay, so between 0 and 90, tan is also positive. So between 90 and 180, tan's actually negative. 180 and 270 is positive, and then between 270 and 360 is negative. All right, it's a really bizarre shape. That's essentially what you come out with. Okay, so in between 90 and 180, tan is negative. Between 180 and 270, tan is positive. Between 270 and 360, tan goes back being negative. Okay, so what the hell does that help with? If we bring all of them together, we've got y equals sine x. Y equals cos x. Okay, we've got y is tan x. Okay, and we can bring that cast diagram together. Say all of them between 0 and 90 are positive. Only sin x between 90 and 180 is positive. Cos x is negative. Tan x is negative. Only between 180 and 270 tan x positive. Sin x is negative. Cos x is negative. Only between 270 and 360, completing that rotation, completing that one wave, okay, is cos x positive. The rest are negative. That allows us to come up with our solutions when we rearrange some of these, okay, when we rearrange the equations, and that's what we're going to go on to. Okay, easier way to draw that. It's just doing, not that. All sin, tan, cos. All of them are positive between 0 and 90. Just sin between 90 and 180. Just tan is positive between 180 and 270. Just cos is positive between 270 and 360. Okay, when I refer back to the original graphs. We're going to use this to find our solutions. All right, so when we find our solutions in the next part, okay, between 0 and 90, we'll just be left with the solution. Between 90 and 180, we'll have to do 180 minus our solution. Okay, between 180 and 270, this will make more sense when we actually do the questions. 180 plus our solution. And between 270 and 360, will be 360 minus our solution. Okay, so from all that explanation, what you need to take away from it is this, that graph, not graph, but that wee table. Guys, I'm going to shoot and get a big glass of water, okay? Good thing I didn't record that. Okay, so what we need to do, the first thing, is rearrange that. So we're left with the trig expression on its own on the left-hand side. Okay, in this case, it's cos x. So I want to remove everything around that cos x. So that's just isolated on the left-hand side. First thing I'm moving across is that plus 2. Okay, so I'm left with 5 cos x. On the left-hand side, it's 1 minus 2. Tidy that up. Okay, and then I can move over the 5 to leave the cos x on the left-hand side. It's a multiple on the left-hand side, so it becomes a divide, and I get that. Now this is where we stop, and we want to look at the cast diagram, okay, for the first time. What we're looking to see is whether this number here is negative or positive. Okay, If it's negative, my solutions are going to be found in the quadrants in which cost isn't, or cost is negative essentially. Okay, so remember between 0 and 90, the cost graph is all positive. Between 90 and 180, cost graph is all negative. Okay, between 180 and 270, cost graph is all negative. Between 270 and 360, it's all positive. So because at this stage, that's negative 1/5, my solutions are going to be found in between 90 and 180 and 180 and 270. So it's going to be in the S quadrant and the T quadrant. I then solve this, okay? To solve, I'm not putting a negative in my calculator. I'm moving costs to the other side. If I move costs from the left to the right, okay, it becomes costs to the -1. That's the way I write it. And in the bracket, I'm putting positive 1/5. Okay, so I'm getting rid of the negative. So this is what I'm putting into my calculator, and the 1/5 is positive. Okay, so that negative only tells me about what quadrant it's going to be in. To find my answer for x, I'm going to put cost to the -1, which is just a button in my calculator. So shift cost bracket 1 divided by 5. I'm getting 78.5 degrees. Now, that's not my final answer. That answer allows me to find my two solutions. Remember when we drew out the cast diagram in the last one, I said, when we're in the S quadrant, I'm 180 minus my answer. When I'm in the T quadrant, I'm 180 plus whatever answer I've got. So for quadrant S, my answer is 180 minus whatever I found for X. Therefore, 180 minus 78.5 is going to equal 101.5 degrees. My second answer is in quadrant T. So 180 plus what I've found, 180 plus 78.5 is 258.5 degrees. Okay. Any questions on that? Anyone not see where the answers are coming from, what I'm looking at, where I'm taking things, what I'm putting in the calculator? Make sure you can put that in your calculator and you're getting the same answer as me out. Same again, this time, only difference is it says sin x. Same process. 7 sin x plus 2 equals 3. 7 sin x equals 3 minus 2. 7 sin x equals 1. Sin x equals 1/7. I wrote every single line out there. You might be able to miss some out. The important thing is though, I've got sin x and I've got a positive number. That means my solutions will be in the quadrants in which sin x is a positive. Okay, now looking back at my graphs, and you don't need to draw this out, sin x is always positive between 0 and 90, and 90 and 180. Okay. Between 0 and 90, I'm going to have an answer. Between 90 and 180, I'm going to have an answer. Okay, between 0 and 90, my answer will be whatever I find in the calculator. between 90 and 180, it's going to be 180 minus whatever I find. Solving that then, bring sine to the other side, sine to negative 1, 1 over 7. That's what I put in my calculator. Sine to negative 1 divided by 7. Getting 8.2 degrees. Quad A, x equals the answer, so 8.2. Quad S, it is 180 minus x, 180 minus 8.2 is 171.8. Okay, exact same process. We're solving the equation. There's a trig involved and it's between 0 and 360. Okay, all those indicate I'm using that cast diagram. Any question? Cool. I'll just do this one more time. Okay. Solve. We've got a trig between 0 and 360. This one's just showing a tan, so that's fine. That's no problem. It's the exact same way. Tidy it up. 2 tan x equals negative 4, negative 5. 2 tan x equals negative 9. Tan x equals negative 9 over 2. Again, you don't need to draw the graph. Okay, so where is tan? Where is tan negative? Tan is negative between 90 and 180. And tan is negative between 270 and 360. Negative, negative. So our answer is going to be again 180 minus x and 360 minus x quadrants. Okay, so at this stage we've got a negative number. Where is that going to be negative? What quadrant? Okay. So putting into our calculator, x tan to negative 1 this time, positive number 9 over 2. Okay, shift tan 9 divided by 2. X is equal to 77.5 degrees. Quadrant S is 180 minus whatever we find, so 180 minus 77.5 is equal to 102.5 degrees. Quadrant C, okay, is 360 minus whatever solution we've got, so 360 minus 77.5 equal to 282.5 degrees. What's the note for? Oh, was it no questions? No problem. I'm going to assume that. Nice one. All right, looks good then. So give that a wee try for me. Take 5 minutes. So come back on at 10 to. All right, shouldn't hopefully not take. Okay, I'll just quickly blitz through that. Three sin x plus 4, 6. 6 minus 4 is 2. Sin x equals 2 over 3. So we're positive. All positive between 0 and 90. And on the sine quadrant again. We've been in the sine quadrant every time. Okay, we don't need to do anything. Our calculators. Fancy. Sine 2 divided by 3. 41 degrees. Okay, quadrant A. It's just x. Quadrant S is 180 minus our answer, so 180 minus 41.8 is 138 degrees. Okay, so nice questions. Couple of marks, fly through them. Lovely. All right. All you need to remember is what this means. That cast diagram and how you use it. Okay, but once you get a hang of that, these questions, easy couple of marks. Okay, sometimes 3 marks. You sometimes get a mark for this, and a mark for, mark for both quadrants and a mark for the answer as well in rearranging. Okay, so sometimes worth a wee bit of marks. Want to finish tonight with something a slightly different way they can ask this, usually in the non-calculator paper, and it's something like this. Okay, so let's look at cost. The cost diagram. So we go from positive, cut x, negative, cut x, positive. Roughly okay. So 0, 90, 180, 270, 360. Okay. So one of the ways they can ask that, if that maximum is 1, the minimum is -1. Okay, so that will give us that sort of coordinate there, and that coordinate is start. Okay, remember that coordinate is when x is 0, and the maximum is at 1. X is 180, and the minimum is -1 on the y-axis. Okay, so we can plot coordinates all the way through this. Okay, so when we're at a point in the y-axis, as we're moving up that y-axis, we're able to pull different solutions out. Now, what happens as we're moving up or down the y-axis? Okay, so say we went to y equals 0.5, which is roughly about there. If we brought a horizontal line out, okay, so if we had a line of y equals 0.5, we brought a horizontal line out. That horizontal line cuts our cost graph or cost wave at 2 different locations. So you're going to have 2 different answers. That's essentially what we're saying with these questions. Okay, so for cos 0.5, our solution, let's get this right so it doesn't confuse us. Cos our solution might not be perfectly to scale, be when x is equal to 60. So our coordinate there would be 60, 0.5, for instance. Okay. But that's not the only time that that line 0.5 will cut that. That will also cut that when cost becomes positive again. Okay, that will also cut that when x is equal to 300. Okay, so that another coordinate, that line cuts, is 300.5. Now the same applies at the bottom if we're going underneath. Okay, if we're going negative in the y-axis, if we had a line coming from negative 0.5, so if we had a horizontal line with the formula negative 0.5, again, we're cutting costs in two locations. Okay, cut costs where x was 120. Okay, and I'll cut costs when x is what would x be? 240. Okay, so if we can cut that line, okay, if we're getting an answer of cos x equals 0.5, okay, then we're cutting that graph at two locations. That's sort of what we were doing before. We were rearranging it and working out in our calculators. Why I've drawn that up is another way they can ask that is something like that. So let's have a wee look at what they're telling us there. So if I'm looking at that and it's sort of confusing me, what I would do is I'll just draw the cost graph. Let's draw a bit better than that. I'll start just by drawing a simple wee sketch of costs. Now I know the milestones of 0, of 90, of 180, of 270 and 360. I know where they are. I know where cost is positive and I know where cost is negative. Okay. When cost x is equal to 0.5, so when we're in the x-axis and we're at 60, okay, so when we're in the x-axis at 60, sort of about here, the answer is going to be 0.5. So you can put that in your calculator and just have a wee look. So cos 60 equals 0.5. That's where we're sort of sitting on that graph. All right, so that's our coordinate right there. Okay, 0.5 and 60 degrees. Okay. Okay, so if cos 60 equals 0.5, state the value of cos 240. Okay, so if we've got the answer in the first quadrant, we can then work out the answer in each of the other three quadrants by using cast. So when cos is 60, the answer sits in this quadrant, in the A quadrant. Okay, and the answer is 0.5. So if we've got the first quadrant, we've got it 60. Then if we wanted to find the answer and cos 240, cos 240 is 180 plus 60. So 180 plus, it's in this third quadrant. It's in between 180 and 270. 240 is in between 180 and 200. So we're doing 180 plus that 60 to work out in that quadrant. Now, in that quadrant, okay, cos is going to be negative. So we know the answer that we're going to get, the answer we're going to presume, is going to be negative at cos 240. Okay, cos 240 is 60 away from that position. Okay, we know it's going to follow that same answer. Okay, so cos 60, cos 180 plus 60, which is cos 240, will also give us 0.5, but it's going to be negative in that quadrant. So it's going to give us a quadrant, an answer right here. Okay, so when x is 240, we're going to be negative 0.5. Okay. They could ask that question in multiple different ways. So they give us cos 60 equals 0.5. They could have asked us what would the answer be if it was cos minus 120. Okay, so cos 120 would be in the negative quadrant, so it would be in here. Okay, it's 60, 180 negative 60, so it's the same distance relation. So the 120 minus 0.5. Cos 120 would be negative 0.5. Cos 240 we've worked out is negative 0.5. And also cos 360, oh sorry, not cos 360, cos 300 would be positive 0.5 because it's when x is equal to 60, but in the fourth quadrant. Okay. So if we get given one of the answers in one of the quadrants, we can work out the answer in the other three quadrants. Okay, so we could have been given this answer here and then work backwards for the other three. Or we could have been given when cos 120 equals negative 0.15, what would cos 240 be? And then knowing that the third quadrant is going to be negative, you're going to sort of repeat that. Okay, so if you get given an answer in one of the quadrants, you'll be able to work out the other three quadrants off the back of that just by understanding the shape of that graph. Okay, so this is another way they've asked it. Again, it's the cost graph. They've actually given you the graph this time, which is quite nice of them. When was that? That was just a practice paper. Okay. Part of the graph y equals cos x. Cos 60 equals, oh, in fact, it's the exact same question. No, it's not. They've asked it in a slightly different way. Okay, if cos 60 equals 0.5, state the two values for cos x, which equal negative 0.5. So you know you're working in the negative range for cos. So you're working in quadrant 3, quadrant 2 and quadrant 3. Okay, so you're working in the quadrant between 90 and 180. Okay, 180 minus x and 180 plus x. Okay. So you're trying to figure out where that's going to be negative 0.5. If cost 60 equals 0.5, so if x equals 60 in the first quadrant, in the second quadrant will be 180 minus 60. So again, will be 120. In the third quadrant, 180 plus, so it'll be 240. Okay, so state the values of x for which cos x equals negative 0.5. You're working with a negative, your x values will be in the second and third quadrants. Okay. Written like that, I've seen in the non-calculator a few times. Something like that, it's a wee bit more difficult with layout of it, but that's not saying it's not possible they can ask it. Okay, again, you don't need a calculator for that. Give that a wee go. Okay, give that a wee go. I'll give you until 12 past. I'll give you 5 minutes. All right. Give that a wee go and try and make sense of it. And then we'll call it a night. Nice one. Let's finish off the night then. So, most important thing here, justify your answer. Don't just guess. You're quite funny. You got it right, but don't. Justification. Draw it out. Show an understanding what a cost graph is. Okay. 1, -1 starts at 0. First milestone's at 90. Hits a minimum at 180. 270 is where it cuts the x-axis. 360, it's back up to a maximum. Okay, so that's our graph. What's it asking us? Well, what happens when x is at 90? So cost 90. Y is 0. Okay. Write the following ordinal of size. Cost 90 equals 0. Cost 100 is slightly along to the right. Okay, your scale doesn't have to be perfect, but you can see cost 100 would be negative something. Okay, negative 0.1. Yeah, negative 0.1. Let's leave it at that. We don't need any more detail. Because cost 300, if we go to our next milestone, which is 270, 300 is a wee bit to the right there, we're in the middle there. So cost 300 would be close to 1. So it would be up near 0.9. Okay. So starting with the smallest number there is negative 0.1. So cost 100. Smallest is cost 100. Next is cost 90. And the biggest number there is cost 300. Okay. Justification is that drawing. Okay. You don't need to write an essay for justification. It's just that drawing. Okay. Something could happen with the sign as well. So justify. Say that was rank sine 90, sine 120 and sine 300. Okay, in order, smallest first, and justify. Okay, exact same process, but draw the sine graph. Positive. Okay, so sine 90, your milestone. We're at our maximum. It's at 1. Sine 90 is going to be the biggest. Sine 120 is about here. Okay, on the x-axis. So it's just less than 1. So it's maybe about 0.8. Sine 300 is way over here. Okay. So we're way down at negative 0.8. Okay. So that equals 1. Sine 120 would be 0.8. Sine 300 would be negative 0.8. Smallest number first. Sine 300. Sine 120. Sine 90. And there's my justification. Okay. So get to know those graphs, sketch them, and ask me if you've got any questions.